Hey everyone, this will be the first video for section 11.2, which is all about the law of sines. But before we talk about what the law of sines is, let's go back in time and think about what have we been doing over and over again this semester. The thing that sticks out in my mind is drawing triangles, right? And every time we would draw a triangle, it would be a right triangle, and we could always solve it with what we call right triangle trig. So let's look at a right triangle. Say all we know about the right triangle is two of its sides. You can actually figure out everything else about the triangle. So we can find, if we call this side A, this angle alpha and this angle beta, we can find those things. The way we're going to find them, well, the missing side, you know, Pythagorean theorem, right? So a squared plus 4 squared has to equal 7 squared. A squared has to equal, that'd be 49 minus 16. It's what, 33? And then take the square root. So you get the square root of 33 for A, right? And then how could we find alpha? Well, think about using a trig function. What trig function could we use? Say we want to go with the 4 and the 7. What trig function? Well, 4 would be adjacent to the angle alpha and 7 is the hypotenuse, so we'd use cosine. So we'd say cosine alpha equals 4 over 7. And then we could use the arc cosine to solve this, right? Because we know we just want an acute angle. Alpha equals, I'm going to have to type that in. So let me type that in the calculator. Arc cosine of 4/7, we get that alpha is about 55.2 degrees if you round it. Okay, now how would we get beta? Well, we could use a trig function again, right? But do we have to? Is there an easier way? If you were thinking that there's an easier way, you were right, because the angles in a triangle all have to add up to 180 degrees, right? So beta we could find by just taking the 180 degrees and subtracting what we already know we have inside the triangle, which is a 90-degree angle and a 55.2 degree angle. Right, so beta is going to equal approximately 180 minus 90 minus 55.2 is 34.8. All right, so now we have beta. The nice thing, right, for this is that these all can be solved in the same sort of way. We have methods for solving it, but if we change the triangle even just a little bit, these methods don't work anymore. So let me erase this. Funny story, I don't know if it was in your class video that I made, but the first 10 videos I've made, I've struggled to try to erase the board. And then I discovered that I was calling it a crappy board, but in reality, there was just a plastic sheet that was on the board that I never took off. So once I removed that, now it's great. All right, so I said if I change the triangle a little bit, all you have to do is change it so that there's not a 90-degree angle anymore, and we can't use those techniques. We need new techniques. So that's where the law of sines comes into play. And I'm going to write down the formulas for law of sine. All right, so the law of sines tells us that sine of alpha over A is going to equal sine of beta over B, which also will equal sine of gamma over C. So this works in any triangle. However, you have to know at least one angle side opposite pair. Alright, so you must know at least one angle side opposite pair. What I mean by that is, well, if you have a triangle you have to know, say, alpha and A, which is always across from it. You might need to know those two numbers. Or maybe you know beta and B, but you have to know at least two of those. And then one other piece of information. Okay, so that's what you need to use this. I'm going to give you an example where we have that. So this is example 1. They tell us we have a triangle that has a 13-degree angle for alpha, a 17-degree angle for beta, and we don't know gamma. I lied about that. We know A. We know that A is 5. All right, so let's draw a picture for this. Triangle. That's not very good. This triangle is probably more like this. So if this is alpha, this will be our 13 degrees, we'll say. Beta will be over here, it would be 17 degrees. A has to be across from alpha, so the 5 has to go there. B is across from beta. This is gamma, and this is C. All right, so now we're going to use the law of sines. What you want to do is identify the angle side opposite pair that you have. So let me bust out a different color here. There's our angle side opposite pair right there. And what we can do is write this out. We'll have a sine of 13 degrees divided by 5. Right, that's sine alpha divided by A. And then it's going to equal, and we could use either of these. You don't have to do both, right? You actually go off of what you know. So we happen to know that beta is 17, and we're going to be able to find B. So we'll put sine of 17 degrees divided by B. And then we need to solve this. So we're going to multiply both sides. Actually, what we can do is cross multiply. If you remember that from, I don't know, middle school, right? When you have two fractions that are equal, you can multiply diagonally and set the cross products equal. So B times sine of 13 degrees has to equal 5 times sine of 17 degrees. And now we're in good shape for solving for B, right? We just have to divide by sine of 13 degrees. So B is approximately, let's type this in, 5 sine of 17 divided by sine of 13 equals, I got 6.498. If you didn't get that number, there's a good chance you're probably just in the wrong mode, right? We want to be in degree mode, so make sure your calculator's in that mode. We'll round this to, I don't know, the nearest 10th. So it would be about 6.5. All right, next, we need to figure out gamma, and we need to figure out C. It's very easy to find gamma because we already know the other two angles in the triangle. Remember, they have to add up to 180. So all we need to do, right, to get gamma is take 180 degrees, subtract 13 degrees, and subtract 17 degrees, and we get 150 degrees. All right, and then we need to find C. We cannot use the Pythagorean theorem for this because there's no right angle in the triangle. So to find C, we're gonna have to use law of sines again. I'll write it over here, I guess. We can still say that sine of 13 degrees over 5, let's go with that one. Now that's gonna equal sine of gamma, which is 150 degrees, divided by C, right? So we want to find C. So we're going to go ahead and multiply, well, cross multiply again. So C times the sine of 13 degrees equals 5 times the sine of 150 degrees. Divide by sine of 13 degrees. So we get C is approximately I got 11.1. And that's it. We have all 6 parts of the triangle solved. All right, so we are happy campers, and I'll see you in the next video.